So further to our discussion of MAC addresses, let's talk about ARP poisoning. ARP poisoning is the deliberate manipulation of these MAC addresses. So what is address resolution protocol? We know this from Network Plus already. It is a layer 2 broadcast-based system that maps IP addresses to MAC addresses. You can't send a packet out the door without knowing its MAC address as well as its IP address. It's broadcast-based and there's no authentication, so who knows where these things are coming from. So machines will look in their ARP table to say, oh, if I need to send something to IP address da-da-da-da, I need to attach the MAC address to it. And what happens then is you send out the packet, and it's a frame at that point, and the network interface card will look and go, oh, destination MAC is me, I'll bring it in, and I will send this thing off up to the IP stack. So ARP is a critical part, it's a core component of TCP/IP, the TCP/IP suite. Now, not all layer 2 protocols use ARP, but Ethernet and Wi-Fi certainly do. And machines will keep their own little ARP caches that map MAC addresses to IP addresses, and switches will keep CAM tables that map switch ports to MAC addresses. So an ARP spoof attack is where you are basically sending fake packets out there, typically ARP replies or ARP requests, that make it look like your interface is somebody else's MAC. So everybody thinks, oh, that MAC is that IP or that IP rather belongs to that MAC, not this MAC. And we do it to overwrite a legitimate MAC table in a switch and to overwrite ARP caches in end machines. In this way, people don't, when a machine tries to map an IP address to a MAC address, it puts in the destination IP, but it puts in your MAC, not someone else's MAC. So ARP poisoning is the process of constantly sending out a regular stream. You do it just every few seconds. It's not like at a very fast pace. You send out a regular stream saying, here I am, and my MAC is such and such, and my IP is such and such, and it's not really. And so then this way, the MAC is correct, but not the IP. So people think I'm going to the server IP, but they're sending it to your MAC. And so we flood or we poison the target computer's ARP cache as well as the switch's MAC table with these fake entries. So with ARP poisoning here, it's the deliberate mapping of an incorrect MAC address to an IP address. Actually, with ARP poisoning, the MAC address is us, the attacker, but the IP address is a server that we're trying to impersonate. So we redirect traffic for malicious purposes. It is used on Ethernet and Wi-Fi networks mostly. It allows us to do man-in-the-middle attacks. Packets have to have both IP and MAC addresses. So with ARP poisoning, the MAC is ours, but the IP is some server that we're impersonating. So name resolution and ARP needs to look up the destination. So we're taking advantage of that MAC to IP mapping. So here here's an example in this picture. Let me just zoom in. I've got some kind of default gateway, some kind of router that goes to the internet here. I've got some kind of hub or some kind of switch. And a user would normally send their traffic out the default gateway to the internet. But when we are ARP poisoning, they are instead thinking they're going to the default gateway, 192.168.1.1, but they're actually going to our MAC address, and then we'll relay it to the default gateway while we're capturing everything that they're doing. So different types of ARP poisoning. We use forged ARP messages to divert the communications. The traffic ends up being exchanged through the attacker's machine. We could spoof the client and the server MAC addresses, lie to the switch. We could spoof the default gateway MAC address. Everybody sends to us instead of the router. Different ways of ARP poisoning. It will be a part of packet sniffing, data interception, session hijacking, connection hijacking, voice call trapping, connection resetting, manipulating data, stealing passwords, man-in-the-middle denial of service. All of these are based really on ARP poisoning, or can be based on ARP poisoning. So let's take another look here. Here's us, MAC, the attacker. Our MAC is 131313. How cute. Here is a legitimate victim, and here's a default gateway, and here's a switch. The legitimate victim's MAC address is A0A0. Now, this isn't a real MAC, of course, just to make it easy. The default gateway is 1111, again, just to make it easy. Because we are ARP poisoning, we're sending phony ARP replies. These guys think that 131313 is actually the other person's address. So what we're doing is we're sending out, who owns something? Tell 131313. So this victim will go, oh, okay, so my gateway 192.168.1.1 is actually MAC 131313, and it puts it in its MAC table. And the default gateway goes, oh, that little client who's trying to talk to me, his MAC is actually 1111, or 131313, excuse me. So what I'm doing is I'm poisoning both of these. And I have to do it on a regular basis, like I said. If I stop, then they'll age these out in a couple minutes and they'll restore normal connectivity. So how do we poison an ARP cache? Like I said, you send fake replies with your MAC address associated with the target IP. You send fake replies with your MAC address associated with a default gateway. You send fake replies with the target MAC address associated with your switch port. For man-in-the-middle, we got to poison the ARP cache of both victims. And or we've got to, in fact, we also have to poison the MAC table of the switch, and we need to be on the same network segment, on the same switch. ARP poisoning tools: EtherCap, Cane-Enable, WinARP Attacker, UFASoft Sniff, many other tools as well. Here's just a screenshot of EtherCap. If we look here with EtherCap, the screenshot, we can see that we're listening on a particular interface with particular MAC address, but what we're doing is we are doing a redirect to our redirect connections to us. Man-in-the-middle? Well, it depends on ARP poisoning. So we put ourselves in the middle of a normal conversation. We act as a relay between the client and the server. Now, ARP poisoning is not the only way to do it. So if we look at this picture here, the way it would normally be is the client and server talk to each other. They know each other's MAC address, they know each other's IP address. In man-in-the-middle, or monkey-in-the-middle, they know each other's IP address, but they think each other's MAC address is really you. And so they relay through you. You can also do man-in-the-middle not only with ARP poisoning. You can have phony DNS name lookups. Like a client thinks it's going to a server, but when it looks it up in DNS, you give them your IP. We don't actually change any MAC addresses. Or the client thinks it's going to a server across the internet, and you do what's called an ICMP redirect, which is an ICMP message saying, hey everybody, don't use that default gateway, use me. I'm the one true default gateway. The client, thinking it's going to a server out on the internet, sends to you. And of course you relay, but you pick up everything they're doing. You can also do SSL strip or SSL downgrading, where we put ourselves in the middle between a client and a web server. And that's going to require some man-in-the-middle. We could set up a netcat relay where we have people connect via netcat through us, and then we relay to something else. We could set up a phony access point, a rogue access point, or a phony cell tower. And it doesn't have to be a tower. You know, IMSI catchers are the size of a briefcase. So we can do any of these mechanisms, not simply ARP level man-in-the-middle. All of them require some type of spoofing. If the packets are digitally signed, then it's not going to work. If they're encrypted, we have to be able to get them one side to negotiate down to unencrypted versions. If this server is a web server and you are acting as a man-in-the-middle to the web server, if the web server requires HSTS, the HTTP Strict Transport Security, then it also won't work, because HSTS is a header in the field that goes to the browser that says, Don't you dare ever allow yourself to be negotiated down below TLS. And so then the browser will refuse to make the connection this way. How do we detect ARP spoofing? Well, how do you detect something that's in promiscuous mode? Because this is really the key. See, in promiscuous mode, what happens is you have normally machines, network interface cards, are only supposed to respond when it's their MAC address in the destination. A NIC in promiscuous mode responds no matter what the MAC address is. So what you do is you send out phony ARP requests saying, hey, who owns, and then you put in a bogus IP address that doesn't really exist or that isn't in use. And the promiscuous mode NIC will say, oh, that's me, and it's my MAC. So that's how you catch them. You advertise something with an ARP request asking for something that's fake. And promiscuous mode NIC will automatically respond and say, that's me. And that's how you find out a promiscuous mode NIC. That's how you find out something that is sniffing, that is ARP spoofing. And there are tools you can use. How do you deal with this? You could implement intrusion detection. You could hard code MAC addresses to IP addresses. That's hard to keep track of. Or probably easier, you could just have VPNs between hosts like IPsec so that the spoofing doesn't really work. So that is ARP poisoning.